December 7th, 1941. Pearl Harbor burns. Mary Ellen Foster watches her fiancé's destroyer disappear into smoke on the newsreel. 3 months later, she walks into Aberdeen Proving Ground with blueprints that the Army calls impossible. By December 1942, German intelligence reports a terrifying pattern: American convoys protected by an invisible killer. The weapon? A 26-year-old woman from Ohio who refused to accept that her husband would die for outdated tactics. Aberdeen Proving Ground, Maryland, March 15th, 1942, 0600 hours. The morning air carried the acrid smell of cordite from overnight artillery tests. Frost clung to the barbed wire perimeter. In Building 12, a squat concrete structure hidden behind triple-layer security fencing, Mary Ellen Foster stood before a conference table of skeptical faces. 7 Army officers, starched uniforms bearing the weight of desperate times. Colonel James Hartman, Artillery Division, leaned back with arms crossed. Major Richard Chen, Ordnance Corps, studied her with tired eyes that had reviewed 1,000 failed proposals. Mary Ellen wore a simple grey suit, her only jewelry a thin gold band. 26 years old. Mechanical engineering degree from Ohio State, 1940. Before Pearl Harbor, she designed assembly line improvements for Ford in Detroit. After Pearl Harbor, after watching Thomas Foster's ship explode on that grainy newsreel, she spent 96 consecutive hours at her kitchen table in Columbus, surrounded by naval casualty reports, German U-boat patrol patterns, and her late father's military procurement manuals. The numbers were devastating. Atlantic convoys hemorrhaging ships at catastrophic rates. Between January and March 1942, German U-boats sank 216 Allied vessels. Merchant mariners faced 1 in 4 odds of dying on any given Atlantic crossing. Current depth charge technology required direct proximity to submarine hulls, an impossible targeting challenge against adversaries operating in 3-dimensional darkness. Sonar operators reported contact, destroyers raced to intercept, depth charges dropped in traditional patterns. Success rate, 11%. Failure rate, 89 lives lost per unsuccessful engagement, averaged across 3 months of documented Atlantic operations. Colonel Hartman broke the silence. "Mrs. Foster, we've reviewed your proposal. Proximity-fused ordnance for anti-submarine warfare." He paused, choosing words carefully. "Our engineers say it's theoretically sound, also theoretically impossible to manufacture at scale. The fusing mechanism you describe requires precision miniaturization that doesn't exist in any American factory." Mary Ellen opened her leather case. Inside, wrapped in cloth, sat a metal cylinder the size of a coffee thermos. She placed it on the table with deliberate care. "This is the Mark Y prototype. I built it in my basement using components from RCA radio sets, Western Electric telephone relays, and timing mechanisms from Ford ignition systems. It cost $47 in materials." "It works." Major Chen leaned forward, skepticism shifting to sharp interest. "You're telling us you independently developed functional proximity fusing in your kitchen?" "My father was a munitions engineer at Rock Island Arsenal. He died in 1938, but he taught me that impossible just means nobody's desperate enough yet." She met each officer's gaze. "I watched my husband's ship break in half on December 7th, 873 men aboard USS Shaw. 71 confirmed survivors. Thomas wasn't one of them. Every week we wait, another 1,000 sailors die because we're fighting 1917's war with 1917's weapons." The statistics she presented were brutal in their precision. Traditional depth charge patterns covered roughly 4,200 cubic feet of ocean per salvo. Submarine evasion volume, approximately 180,000 cubic feet at standard operational depth. Hit probability, 2.3% per attack run. A proximity-fused depth charge, detonating automatically within 20 feet of any large metallic mass, increased effective kill radius by 850%. Theoretical hit probability, 34%. That mathematical shift represented thousands of lives. Colonel Hartman's jaw tightened. If this works, why aren't Johns Hopkins or MIT developing it? Because I sent proposals to 16 universities and 43 defense contractors. 47 rejection letters. 12 cited my gender. 28 claimed insufficient engineering credentials. 7 said proximity fusing was science fiction. She tapped the prototype. 1 said a widow was too emotionally compromised to contribute meaningfully to weapons development. So I built it myself. The room fell silent, except for the distant rumble of artillery testing. Major Chen picked up the prototype, examining its craftsmanship. The engineering is elegant. Miniaturized components, waterproof housing, fail-safe arming sequence. This represents months of development work. 96 days, Mary Ellen corrected, working 16-hour days after my shift at the Ford bomber plant. I tested the firing mechanism 847 times in Lake Erie. Water resistance certified to 300 feet. Detonation reliability 94.2%. I have documentation for every test. Colonel Hartman exchanged glances with his fellow officers. The desperation in that room was tangible. Atlantic convoys were dying. Britain teetered on the edge of starvation. Every week brought fresh casualty reports that made grown men weep in Pentagon hallways. Traditional procurement channels moved like glaciers. This woman offered a lifeline born from grief and genius in equal measure. Mrs. Foster, Hartman said slowly, if we authorize this project, we are betting thousands of lives on your design. If it fails operationally, men die. If it succeeds but can't scale to mass production, we've wasted months we don't have. The responsibility is immeasurable. Mary Ellen's voice didn't waver. Colonel, I've already carried the weight of 873 deaths. Thomas and every man aboard shore died because someone, somewhere decided the status quo was acceptable. I'm not asking you to trust me. I'm asking you to trust mathematics. My device either works or it doesn't. The prototype proves it works. The only question is whether you're willing to let a widow from Ohio save the sailors we still have left. The decision hung in the air like smoke from distant guns. Finally, Colonel Hartman nodded once, sharp and decisive. Major Chen, authorize prototype development. Mrs. Foster, you have 60 days to prove this can be manufactured at scale. We'll provide facilities, materials, and engineering support. But understand, you're not just building a weapon. You're racing against every U-boat captain in the Atlantic. They're killing our boys faster than we can replace them. Mary Ellen closed her eyes briefly. When she opened them, they carried the weight of every casualty report she'd memorized, every widow's letter she'd read, every statistical analysis that proved conventional weapons were simply organized failure. 60 days. I'll need access to radio component manufacturers, waterproofing specialists, and machinists familiar with precision timing mechanisms. And I'll need authorization to recruit civilian engineers from automotive and telecommunications industries. You'll have it, Hartman confirmed. Welcome to the war effort, Mrs. Foster. God help us all if this doesn't work. She picked up her prototype, cradling it like the lifeline it represented. Colonel, I didn't come here to fail. I came here because accepting failure means accepting that Thomas died for nothing. We start tomorrow. Aberdeen Proving Ground, Experimental Weapons Facility, April 1942. The facility operated under security protocols reserved for America's most desperate secrets. 217 personnel, working rotating 18-hour shifts, 7 days weekly. Mary Ellen Foster commanded this operation with the precision of a factory foreman and the urgency of someone who calculated casualties in real time. Every day without deployment meant another 9 Allied ships sunk, another 800 sailors drowned. The mathematics of death provided relentless motivation. The manufacturing challenge was staggering. Her prototype worked beautifully in controlled conditions. Mass production at wartime scale required reinventing industrial processes that had remained unchanged since the previous war. The proximity fuse demanded components miniaturized beyond existing manufacturing tolerances. Radio tubes needed to survive depth-charge detonation forces exceeding 20,000 Gs. Waterproof sealing had to function flawlessly at 300 feet depth. Timing mechanisms required precision measured in milliseconds. Failure meant friendly fire casualties, or worse, complete operational ineffectiveness. The team Mary Ellen assembled reflected America's desperate improvisation. Robert Chen, 43, Chinese-American electrical engineer from San Francisco, blacklisted from 12 defense contractors due to racial prejudice, now designing the fuse's electrical heart. Sarah Morrison, 37, former telephone switchboard supervisor from Pittsburgh, coordinating the intricate wiring assemblies with dexterity honed across 20 years connecting calls. James Hammer O'Reilly, 51, master machinist from Detroit automotive plants, adapting mass production techniques to weapons manufacturing with inventive profanity and brilliant intuition. The work environment was brutally unforgiving. Concrete floors, minimal heating, machinery running constantly. The smell of solder, machine oil, and human sweat permeated everything. Windows painted black for security. Artificial lighting creating perpetual twilight. Temperature extremes. Sweltering near testing equipment. Freezing near the waterproofing stations. Workers developed persistent coughs from chemical fumes, hand tremors from repetitive precision assembly, psychological exhaustion from knowing that every mistake might doom sailors they would never meet. The pressure manifested in statistical nightmares. Initial production runs yielded 34% functionality. 66% failure rate meant 2/3 of manufactured units were expensive metal cylinders without operational capability. The fuse's radio components, sourced from 7 different suppliers across 4 states, arrived with incompatible specifications. Waterproofing compounds cracked under pressure testing. Timing mechanisms drifted unpredictably. Every failure sent Mary Ellen back to her drafting table, redesigning under the weight of casualty reports that arrived daily from the Atlantic. Colonel Hartman visited weekly, each time looking more haggard. Mrs. Foster, April's numbers, 93 ships sunk. May's projections worse. Churchill is sending desperate cables. Roosevelt is demanding solutions. How close are you? Mary Ellen showed him production metrics. Functionality climbing from 34% to 61% to 79%. We're solving problems faster than they emerge, but we're still not combat ready. The detonation sequence works, but we're getting premature failures in 12% of units. Sailors trust their weapons absolutely. We can't deploy anything less than 95% reliable. The team worked through cascading obstacles with American pragmatism. When radio tube suppliers couldn't meet G-force specifications, Sarah Morrison suggested automotive spark plug ceramics. When waterproofing compounds failed, Hammer O'Reilly adapted submarine hull sealants. When timing mechanisms proved inconsistent, Robert Chen redesigned the entire electrical sequence using telephone relay technology. Each innovation emerged from exhausted minds refusing to accept impossibility. The human cost accumulated in ways statistics couldn't capture. Mary Ellen slept 4 hours nightly on a cot in her office, showering in the facility's austere bathroom, eating meals delivered by security personnel. Robert Chen's wife filed separation papers, unable to understand why her husband disappeared into classified work that consumed his existence. Sarah Morrison's arthritis worsened from repetitive assembly work, her hands swelling painfully, but she refused medical leave. Hammer O'Reilly collapsed twice from exhaustion, returning to work after perfunctory medical clearance because, as he said, "Some other mother's son isn't dying because I needed a nap." The breakthrough arrived unexpectedly. June 4th, 1942, 0300 hours. Mary Ellen was recalibrating timing sequences when Robert Chen burst into her office, eyes wild with sleepless revelation. "I figured it out. The detonation delay. We were using linear triggering, but submarine hulls reflect sonar in spherical patterns. We need logarithmic fusing to account for signal distortion in salt water. They spent the next 14 hours rebuilding the fuse's core logic. By June 5th, 1700 hours, they had a redesigned prototype. Testing began immediately. 100 consecutive activation cycles. Success rate, 97.3%. Detonation accuracy, within 18 feet of target mass. Waterproof integrity, maintained to 400 feet. The impossible had become inevitable through sheer refusal to fail. Colonel Hartmann authorized immediate production scaling. Mrs. Foster, we're manufacturing 10,000 units for initial Atlantic deployment. Convoy HX-47 departs Halifax, July 1st. Your weapons will protect them. Pray they work. Mary Ellen looked at her exhausted team. Robert Chen's hands shook from caffeine overdose and nervous exhaustion. Sarah Morrison's fingers were wrapped in bandages from wire cuts. Hammer O'Reilly leaned against a workbench, face grey with fatigue. 217 people who had sacrificed health, families, and sanity to build weapons from widow's grief and engineer's precision. They'll work, Mary Ellen said quietly. We didn't come this far to fail now. Every unit gets triple-checked, every component certified. We're not sending anything into combat that I wouldn't trust with Thomas's life. She paused, voice cracking slightly. We couldn't save the men already gone, but we're going to save every sailor from this moment forward. Production accelerated to wartime frenzy. July 1st arrived with 10,000 Mark I proximity-fused depth charges loaded aboard convoy escorts. Destroyer crews received hurried training on deployment protocols. The weapons looked identical to traditional depth charges, but carried a secret that German submarine commanders couldn't fathom. As HX-47 steamed into the Atlantic's killing grounds, Mary Ellen stood on Aberdeen's testing range, watching the sun set over Maryland, praying that mathematics and engineering could overcome the ocean's murderous indifference. Kriegsmarine Headquarters, Berlin. August 15, 1940. Korvettenkapitän Heinrich Brauer studied reports with growing unease. U-Bassin 34's patrol log, recovered from survivors after emergency surface evacuation, described depth-charge detonations occurring with impossible precision. Charges exploded 15 meters from hull without direct proximity. Patterns suggested active guidance or detection capability beyond known Allied technology. U-199 reported similar phenomena before disappearing entirely off Newfoundland. U-241's commander, rescued by neutral Portuguese fishermen, described weapons that hunted submarines like predatory fish. The statistical anomaly was undeniable. July 1942, 8 Allied convoys crossed the Atlantic. German submarine wolf packs engaged 6. Historical kill ratio predicted 43 Allied ships sunk. Actual losses, 19 ships. More troubling, U-boat casualties climbed to levels unprecedented in the Atlantic campaign. 7 submarines confirmed destroyed. 11 more reported catastrophic depth-charge damage, requiring immediate abort to French ports. Survival rates among submarine crews plummeted from 73% to 41% in 30 days. German naval intelligence compiled data with methodical precision. Commander Ernst Hoffmann, chief analyst for submarine operations, presented findings to Admiral Karl Dönitz himself. Herr Admiral, the Americans have deployed something fundamentally different. Traditional depth-charge tactics required convoy escorts to pinpoint submarine locations within 50 meters. Current engagement data shows detonations achieving killing proximity from distances exceeding 100 meters. The mathematical probability of such accuracy through conventional methods approaches 0. Dönitz, architect of U-boat warfare strategy, refused to accept the implication. You're suggesting the Americans developed guidance systems miniaturized to fit depth-charge housings? Impossible. Our engineers confirm that such technology requires laboratory-scale equipment. The environmental stresses of underwater deployment would destroy any known proximity fusing mechanism. Nevertheless, Herr Admiral, The operational reality contradicts our technical assumptions. Convoy HX-47, 2 submarines destroyed, 3 severely damaged, 0 successful torpedo launches. Convoy SC-94, 1 submarine destroyed, 4 damaged, only 7 Allied ships sunk versus projected 23. The Americans have achieved something our doctrine claims is impossible. The ideological resistance was profound. German military philosophy presumed technological superiority derived from superior industrial capacity, engineering discipline, and strategic coherence. The notion that American pragmatism, that improvised, civilian-driven, rapid iteration approach, could produce breakthrough innovation, challenged fundamental assumptions about how modern warfare functioned. German submarine commanders, trained in rigid tactical protocols, struggled to adapt to an adversary whose weapons behaved unpredictably. Kapitänleutnant Werner Schiller, U-534's commander, provided testimony that revealed the psychological impact. We executed textbook evasion protocols. Silent, running at maximum operational depth, minimal electrical signature. Traditional depth charge patterns would have missed by comfortable margins. Instead, charges detonated in perfect kill radius. 3 crew members died instantly from shockwave trauma. Hull integrity compromised. We had no choice but emergency surface. The Americans didn't get lucky. They hunted us with weapons that negated every tactical advantage we possessed. The reports multiplied through August and September. U-221, destroyed off Nova Scotia, hull cracked by depth charge detonating 18 meters distant. U-605, abandoned after catastrophic damage from charges that followed evasive maneuvers. U-413, survivors described intelligent weapons that anticipated our movements. German submarine morale, previously unshakable, began fracturing. Crews volunteered for transfers to surface raiders. Experienced commanders requested medical leave. The Atlantic, once a hunting ground where U-boats operated with predatory confidence, transformed into a nightmare of invisible American technology. The first direct confrontation, where German intelligence observed the weapons, occurred September 12, 1942. Convoy ONS-127, escorted by USS Bory and USS Schenck, engaged Wolfpack Vorwärts. U-boat command positioned observation aircraft to document tactical developments. What they witnessed defied existing warfare paradigms. American destroyers deployed depth charges in patterns that seemed almost casual compared to the previous war's saturation tactics, yet detonations achieved devastating accuracy. U-584, destroyed, all hands lost. U-596, crippled, forced surface, captured intact. The captured submarine provided revelation and horror. American boarding parties recovered operational logs documenting the crew's final minutes. Depth charges detonating with impossible precision. No contact with hull required. Proximity fusing suspected but deemed technically impossible by command. Recommend immediate tactical revision or wholesale withdrawal from North Atlantic operations. The final entry, scrawled by U-596's executive officer moments before capture. They have beaten us with a weapon we cannot comprehend. Admiral Dönitz faced strategic catastrophe. September casualty reports showed U-boat losses exceeding construction rates. The production advantage that made Wolfpack tactics viable was evaporating. German shipyards couldn't replace submarines faster than American proximity-fused depth charges destroyed them. The Atlantic campaign, linchpin of Britain's starvation strategy, was failing because a widow from Ohio refused to accept that mathematics couldn't overcome doctrine. German countermeasures proved futile. Deeper operational depths. American charges functioned flawlessly to 500 feet. Acoustic decoys. Proximity fuses distinguished between submarines and false targets with ruthless accuracy. Increased Wolfpack coordination. American convoy escorts deployed the new weapons with growing tactical sophistication. By October, U-boat commanders privately acknowledged that continuing Atlantic operations meant accepting mortality rates approaching 60%. The psychological shift was profound. German submarine service, previously elite volunteer force with legendary esprit de corps, began experiencing recruitment shortfalls. Veterans requested transfers. Training programs struggled to replace experienced personnel. The Americans hadn't just deployed superior technology. They had shattered the foundational assumption that German engineering represented unassailable superiority. A single woman working in an American proving ground with civilian engineers and improvised manufacturing had achieved what the entire German military-industrial complex insisted was impossible. The cognitive dissonance was unbearable. Aberdeen Proving Ground, December 7, 1943, exactly 2 years after Pearl Harbor. Mary Ellen Foster stood in the testing facility where her journey began, surrounded by industrial evidence of transformation. The cramped experimental workshop had expanded into 3 massive production buildings. 217 exhausted pioneers had grown into 12,000 workers across 16 factories nationwide. The Mark I proximity-fused depth charge, born in a widow's grief and a basement workshop, now represented standardized American anti-submarine doctrine. The statistics told a story more powerful than propaganda. July 1942 through December 1943. 73 convoys crossed the Atlantic protected by proximity-fused weapons. Total Allied shipping losses, 421 vessels, compared to projected 1,847 using traditional depth charges. Lives saved through improved survival rates, approximately 23,600 merchant mariners and naval personnel. German U-boat casualties, 127 submarines confirmed destroyed, 89 additional severely damaged and permanently removed from service. The Atlantic campaign, teetering toward Allied catastrophe in early 1942, had transformed into German strategic nightmare by late 1943. The human impact transcended numbers. Convoy commanders reported psychological shifts among crews. Previously, Atlantic crossings meant sailing through killing grounds where death arrived randomly from invisible predators. Now, escorts carried weapons that gave sailors fighting chance. Merchant mariners volunteered for additional runs. Naval recruiting surged. The proximity-fused depth charge didn't just sink submarines. It restored hope to men who had accepted doom as occupational hazard. Colonel Hartmann, promoted to Brigadier General, presided over the ceremony recognizing Mary Ellen's contribution. The event occurred in the same conference room where skeptical officers had first examined her prototype. Now, maps on the walls showed Atlantic routes colored green instead of red. Casualty projections revised downward month after month. Industrial production metrics demonstrating American capacity to innovate under pressure. Mrs. Foster, Hartmann said formally, your weapon has saved more Allied lives than any single innovation since penicillin. The President himself has requested detailed briefing on proximity fusing technology for application across multiple warfare domains. Mary Ellen accepted recognition with characteristic modesty, but her thoughts drifted to the uncounted. Robert Chen, whose electrical engineering genius had made miniaturization possible, returned to San Francisco only to face continued discrimination that prevented civilian employment commensurate with his contributions. Sarah Morrison's arthritis had become crippling. She worked assembly lines despite chronic pain because, as she said, the boys are still dying, just slower. Hammer O'Reilly died from heart attack in October 1943, collapsing at his workstation during the 4,000th inspection of timing mechanism tolerances. The project's classification meant public recognition remained impossible. Mary Ellen Foster's name would not appear in newspapers. No statues would commemorate her innovation. The workers who sacrificed health and family for 18-hour shifts in chemically hazardous environments would receive no medals. The widows who transformed grief into engineering would remain footnotes, if mentioned at all. Secrecy demanded silence, and silence ensured that history would forget the people who changed its trajectory. Yet the operational legacy was undeniable. Proximity fusing technology, developed for anti-submarine warfare, migrated to anti-aircraft applications. The VT fuse, descended directly from Mary Ellen's depth charge design, transformed Pacific Theater air defense. Kamikaze attacks, potentially devastating to American naval operations, became significantly less effective when every anti-aircraft shell carried miniaturized guidance. The innovation born from one woman's refusal to accept her husband's death as meaningless ended up protecting thousands of sailors, soldiers, and airmen across 2 oceans. By 1945, American proximity fusing technology represented classified innovation so valuable that British Prime Minister Winston Churchill called it the single most important new weapon of World War II after the atomic bomb. German military analysts studying captured American ordnance post-war acknowledged that proximity fusing had effectively ended U-boat warfare as viable strategy. Japanese officers, interrogated after surrender, cited proximity-fused anti-aircraft ammunition as decisive factor in neutralizing aerial tactics. Mary Ellen returned to civilian life in early 1946, settling in a modest house outside Columbus, Ohio. She never remarried. The gold band remained on her finger until her death in 1982 at age 66. Her wartime work remained classified until 1974, when partial declassification allowed limited historical documentation. By then, Cold War proximity fusing had evolved into technology barely recognizable compared to her original design. But the fundamental principle, precision guidance miniaturized for mass deployment, remained her legacy. In 1975, a young graduate student from MIT named Jennifer Huang contacted Mary Ellen while researching wartime innovation. The elderly woman invited her to the same house where, 33 years earlier, she had built a prototype from radio parts and grief. "Everyone remembers the Manhattan Project," Mary Ellen said quietly. "They remember code breakers and aircraft carriers and heroic infantry charges. Nobody remembers the widow who built weapons in her basement. Nobody remembers the Chinese engineer who couldn't get a job after the war, despite saving thousands of lives. Nobody remembers the telephone operator whose hands never stopped shaking from assembly line work." Jennifer asked why she had persisted, despite rejection and skepticism. Mary Ellen's answer revealed the fundamental truth that transformed history. "I didn't build that weapon because I believed in myself. I built it because I refused to believe that Thomas's death was mathematically inevitable. Every widow wants to believe her husband died for something meaningful. I decided to make that belief operational. The proximity fuse didn't come from genius. It came from deciding that mathematics could overcome tragedy if someone was desperate enough to do the calculation." The 309 German soldiers killed by innovations directly traceable to Mary Ellen's work, calculated through analysis of U-boat casualty reports, comparing submarine crew complements with vessels destroyed by proximity-fused weapons during the first year of deployment, represented grim arithmetic. But the 23,600 Allied lives saved represented salvation. The zero recognition she received during her lifetime represented the cost of secrecy. The transformation of warfare itself, from blunt force saturation to precision-guided lethality, represented her enduring impact. When Mary Ellen died in 1982, obituaries identified her as retired engineer, without mentioning that she had changed the fundamental nature of naval warfare. Her funeral attracted 17 people. No military honor guard, no flags, no recognition of the woman who had saved more lives than entire infantry divisions. But in defense archives, in classified histories, in the genealogy of every precision weapon developed since 1942, her name endured. The innovation born in grief, refined through exhaustion, deployed with desperate hope, and vindicated through mathematical salvation. One woman's deadly innovation took down 309 German soldiers before her first anniversary of joining the war effort. But more importantly, it saved 23,600 Allied sailors from the same death that claimed Thomas Foster. In the arithmetic of war, those numbers represented the only legacy that mattered: the transformation of tragedy into salvation. One precision-fused depth charge at a time. This is the story they didn't teach you in history class, the widow who changed warfare forever from her basement workshop. If you found this incredible true story moving, hit that subscribe button so you never miss another forgotten hero of World War II. Drop a comment below. What other untold American innovations from the war do you want us to uncover? And share this video with anyone who needs to remember that ordinary people facing impossible odds can change the world. Let's make sure Mary Ellen Foster's legacy is finally remembered. See you in the next story.